For the most part, solving with inequalities works just the same way as solving an equation. We still want to isolate the variable on one side by itself. Where the difference will come will be in the ways that we can express our solution. For example, the one that is here, 3x minus 10 greater than or equal to 8. First thing we need to all agree on is that the symbol here means greater than or equal to. If it were facing the other direction, it would say less than or equal to. Notice that we solve in just the same way as we did with an equation. We're isolating the variable by first adding 10 to both sides. 8 plus 10 made 18. Then dividing everything by 3. 18 divided by 3 is 6. So our solution, x greater than or equal to 6. One way for us to express that solution is in inequality notation, where it's written just like this, x greater than or equal to 6. A second way for us to express our answer is on a graph, on a number line. What we'll do is locate the critical value, the important number, 6, that was part of our solution. From there, things that are greater are out to the right. So to represent that this is part of our solution set, we'll shade it heavily out to the right of the 6. Notice that if you have the variable on the left-hand side of the inequality, the arrow is telling you which way you should shade it. Now at 6 itself, since we have an equals, we need to include 6 as part of our solution. The way that we do that in Math 112 is to put a bracket facing the direction that we've shaded. If you look at that bracket, if you were to take away the part in the middle here and look just at the top and the bottom, it would appear to be an equal symbol. So anytime you've got equals as part of your inequality, a bracket will be the symbol that we use. Now, the third way for us to express our answer is what is called interval notation. The way we can find our interval notation is looking at the graph, starting on the left-hand side and moving across it from left to right, writing down the things that we see. As I come across my picture, the first thing I see is a bracket. It happens at 6. Now, this interval goes forever. The fancy math person way of saying forever is infinity. Looks like a sideways 8 there for the symbol. So this interval begins at 6 and it's included, and it keeps going forever. Notice here that with infinity I've put parentheses. Since a bracket means that the number that we're talking about is included, I can't use a bracket with infinity. There is no biggest number for us to be equal to. To close the interval off, then, we use parentheses. Anytime that you've got a negative infinity or a positive infinity, a strictly greater than or a strictly less than, then you'll use parentheses. But when you're equal to something, that's when we have the bracket. Now let's look at how this same problem could be worked again with one little tiny change. It's now strictly greater than. The problem solves in exactly the same way. We're still shading forever out this way to the right of 6. But this time 6 is not part of our answer. Since it's not part of our answer, we had a strictly greater than. That means we'll put parentheses on our picture. This also changes our interval notation. As we look at the picture coming across the page from left to right, it begins with parentheses at 6. It goes forever, so it's still going to infinity, and infinities always get parentheses around them. The difference between these two pictures is very important for us to see. If the 6 is included, we want a bracket. If the 6 is not included, we want parentheses. Let's look at a little bit harder inequality for us to try to solve. For instance, this one. First, let's isolate the variable on one side. That means I need to subtract 13 from both sides. This would give me minus 5x greater than or equal to, if we subtract 13, minus 2 minus 13 is minus 15. Now, here's one of the tricks that we have to be aware of with inequalities. Anytime that we divide by a negative, if we are dividing by a negative, then we must change the direction of the inequality symbol. Every time that we divide or multiply by a negative, the direction of the inequality must change. Negative 15 divided by negative 5 is positive 3. So here is our solution in inequality notation. If I were to try to graph this, our critical value is at 3. Notice this time, with the variable on the left-hand side, the arrow is pointing to the left. So things that are less than 3 are on the left-hand side. At 3 itself, should it be included? We've got that equals. Equals gets a bracket. Now our interval notation this time maybe is a little bit tricky. We start on the leftmost side. It says go forever that way. If positive infinity is over here, then negative infinity must be over there. That means that our interval notation, we begin with parentheses at negative infinity. Just like there's not a biggest number, there's not a smallest number either. So any kind of infinity gets parentheses. Now where does our picture stop? It stops at 3, and 3 was included, so we do put a bracket there for it. Then one more that has a little bit of a trick to it. Here we need to simplify a little bit before we can begin the solving process. Let's distribute into the parentheses. This is minus 4z plus 32. Negative 4 times negative 8 made positive 32. This is strictly greater than 3z minus 3. Now, as we go to solve this, it's a good idea for you to always have your variable on the left-hand side so that your symbol will make sense to you. So where I want to begin to solve this, let's take the 3z and let's move it to the left-hand side. It was a positive 3z, so as I now subtract 3z from both sides, this gives me minus 7z plus 32 is greater than negative 3. Now it looks the way we like for them to look. So let's move the 32 across, subtracting it, and let's divide by minus 7. Now again, if we are dividing by a negative, you flip the direction of the inequality. So this says z is less than 5. As I draw my picture, the critical value was at 5. Things that are less than 5, I'm shading to the left. And at 5 itself, we need parentheses since 5 is not included. Our interval notation goes from negative infinity up to 5. We've got parentheses on both sides because an infinity always gets parentheses, whether it's negative or positive. We've got parentheses on the right-hand side because the 5 was not included.